Okay, the second part in our video related to odds, risk, rate, and hazard ratio interpretation from epidemiological studies. Again, these are foundational principles for environmental health and epidemiology, and this next video is more of the applied aspect of what was covered in the first video. And it will use a variety of examples, not so much from epidemiological studies, but there is some mention of that in here, and we'll go from there. So I've got several different odds ratios plotted on a scale. We see numbers that range from 0.85 all the way up to 4.8. We're going to go through these right now, and you can tell me whether or not they appear to be harmful or protective, and then we'll, or at least think of that on your own as we go. So 0.9, does that seem harmful or protective? You should probably answer protective. Numbers less than 1 are protective. So 4.8, that suggests harmful. 0.85 suggests that it would be protective. 1.25 and 1.45, they suggest harmful or more exposure, more of the disease, or more exposure, more of the outcome of interest. And then 1.0, that suggests no association, not harmful or protective. That information's only good with regards to an estimate. It's not very helpful unless it takes into consideration the sample size of the study or the number of variables in the sample size being looked at, which is captured with a 95% confidence interval. So these are just preliminary estimates. So using these same numbers, we need to be able to determine with a 95% confidence interval that goes around those if something is significantly harmful or significantly protective, or if it's inconclusive or insufficient evidence to suggest such. So here on this little figure, we have the 95% confidence intervals depicted by the actual yellow lines. These are the same numbers as before, but this time we have a 95% confidence interval number drawn on there for you. So for letter A, letter B, letter C, letter D, letter E, and letter F, you should be able to go through those and make a determination of whether or not they are significant or not. So letter A, does the 95% confidence interval cross 1? No, it does not. This is all in the protective range. So we would say that that is significant. Letter B, does it cross the range in any way? No, all of it is above the number of 1. It is entirely harmful, so that is significant. What about C? C crosses 1. So does D. So does F. Are those significant or not? So take a second to look over those. Make a few mental notes to yourself of whether or not you think that all of these are significant, whether or not E is significant. The whole confidence interval for E is above 1. So we know that that's harmful, but is this significantly harmful? So on the next slide, we go ahead and we actually say yes or no on all of those. So you can see the whole confidence interval is protective. So yes, it's significantly protective. Here, the whole confidence interval is above 1. It's significantly harmful. This one crosses 1. You see that? It crosses 1. So this is harmful. This is all protective. It suggests protective at first, but it's not statistically significant. So there's no association able to be determined there. It includes 1. Same thing here. It includes 1. This one, does it include 1? No. In fact, it's all above 1. So yes, it is significant and it's significantly harmful. And then this last one, it was right on the magic number of 1 already, so that suggested no association. And is it significantly harmful or protective? Well, it goes on both sides of 1, so it's not significant. We can say something about the p-values for these as well. If there's a statistically significant difference, we have a less than 5% chance of making an error in our assumption that something is significant or not. So these are 95% confidence intervals, so 1 minus 0.05 is 95%. So there's less than 5% chance that our estimate is wrong. So we'd say that this is significant, and because it's significant, the p-value, the probability of making an error in our judgment of whether something is protective or not is less than 5%. So p is less than 5% or less than 0.05. This one, although, look, see the p-value? Again, less than 0.05. It's statistically significant. There's less than a 5% chance of error that we would err on saying that this is something different than this is significantly harmful, and we are over 95% certain that it's significantly harmful. There's a less than 5% chance of error in our statement that this is harmful. Here, it's not significant, so the p-value is greater than or equal to 5%. So if we said that that was protective, like the estimate, there would be a greater than 5% chance that we were wrong. So we would say that that's not statistically significant because p is greater than 0.05. Another one that's not significant, p is greater than 0.05. And another one here that is significant. So statistically significant means that there's a less than 5% chance with a 95% confidence interval that we're going to err in our determination. And then down here, p is greater than 0.05. It's not statistically significant. When we're talking about statistical significance, we're asking ourselves, is there a statistically significant difference between the exposed and the unexposed with regards to the risk of illness? So in this example, all of these that are not significant, there's no difference. Let's look at some other ones. So take a second, you can hit pause on this, make some notes of whether or not you think it's significant or not, and then continue on with the video. So we got letter A, B, C, D, E, and F. So take a minute to look at those, pause it, and make your determination. Is this significant or not? So here are the answers. Any of these ones that cross this line of 1 or include 1 in the confidence interval are not significant. So that's not significant, that's not significantly different, and that's not significantly different. There's no statistically significant difference between the exposed and the unexposed. Although they seem protective, these are harmful, harmful, no association. We need that confidence interval. So this one is statistically significant, this one's statistically significant, this one's statistically significant. 1 is not included in the confidence interval of any of those. Now I've got some actual numbers. So we're going to go through these individually and make a determination of whether it suggests protective or not. So 0.90 is our odds ratio. Estimate, does that seem protective or harmful? Well, it's less than 1, so it suggests protective. 1.20, harmful or protective? It's above 1, so it suggests harmful. 0.70, it's below 1, so it's protective. 1.32, that's above 1, so guess what? That is harmful. 0.50, 0.50, it's below 1, so that suggests protective. 0.45, that is also below 1. It suggests protective. These are our initial estimates, protective or harmful. Now, what's more important is, are we 95% confident that it's significantly protective or harmful, or is it not significant? So let's look. 0.9 fits in the range of its confidence interval like it's supposed to. It should always, unless there's a mistake. So we're looking to determine statistical significance based off of these numbers here. And 1 is included. This 0.8 suggests protective. 0.25 suggests harmful. We have numbers on both sides of 1. So guess what? You can't say that there's a significant effect because you've got protective and harmful information from that 95% confidence interval. 1 is included in that number, so it is not significant. Again, the number 1 falls in this range, not significant. What about here? Is 1 included between 0.6 and 0.8? No, 0.7 is in there, but not 1. So it is protective. That is protective. The whole thing, the whole 95% confidence interval is protective. So it is significant. And this is significantly protective. 0.8 to 1.7, 1 is included. So we have protective and harmful. 1 is in the middle, not significant. Again, 1 is included in letter E's confidence interval, not significant. And then letter F, we have 0.2 to 0.8. It is entirely protective. There is no number 1 in there. So it is significantly protective. Moving on. Some different numbers. So p-values, right? P-values. So if something doesn't include 1, then it's significant. But in cases of things that do include 1, where we have, again, protective and harmful, we have a statistically significant result on this one and this one, but these, that's not significant. So if we said it was, there would be a greater than 5% chance of error. So we would say it's not statistically significant, and the p-value would be greater than 0.05. Letter B, the p-value for this, it's not significant, so it would be greater than or equal to 0.05. For things that are statistically significant, we are at least 95% confident that we are making the right determination, so it is statistically significant. So p is less than 0.05. Here, 1 is included. It's not statistically significant, so p is going to be greater than or equal to 0.05. 0.5 to 1.4. Again, not statistically significant, so p will be greater than or equal to 0.05. Letter F. 1 is not included in there. Guess what? It's statistically significant, so p is going to be less than 0.05. We got some different numbers here now. Our initial estimate here suggests what? Protective. 1.20 suggests harmful. 0.70 suggests protective. 1.32. 1.32 is above 1, suggests harmful. 0.50, that's below 1, suggests protective. 0.45, that's below 1, suggests protective. All right, I'm going to pause it here, and we're going to do another video that has the second round of practice. So that'll be our third video in this series, and I'll be able to slow that one down even more because we'll have a little bit more time. So we'll pause it here, and be sure to watch video number 3 for the second round of practice.